DNP3 Basics Summary. There was a lot presented in the previous lessons, and it was a long time since the first. So perhaps we should present one or two messages that show everything and parse them together. Let's take one request and one response. This diagram shows the order of components in a DNP3 message. A message starts with the data link layer, is followed by the transport octet, and then the application layer. That layer consists of a header, internal indications if the message is from the outstation, and a set of objects. I am sure you all knew that, but I just wanted to say it again. Here is the request, starting with the data link layer. It starts with hex 5 and 64, identifying the message as DNP3. The length is hex 11 or 17. The control octet is a hex C4, unconfirmed user data with the primary and direction bits set. The next two octets are the destination address 1, and the next two octets are the source address 0. The data link ends with the two CRC octets. The next octet is the transport with fin and first set and sequence number 0. The application area starts with the application control octet hex C7 with fin and first set and sequence number 7. The function code in the header is 1 for read. The first object is hex 3C or 60 decimal for class data, and variation 2 for class 1 with qualifier 6 for all. This is followed by similar headers for classes 2 and 3. Two CRC octets finish the application area and the message. Okay, that was easy, probably a lot easier than you thought it was going to be. Therefore, I will let you do the response by yourself. Okay, I see some of you might be having problems, so let's go through this together. Here is the response data link header, which again starts with 564. The length is hex 2A or decimal 42. The control octet is hex 44, which has the primary bit set and a function code of unconfirmed user data. The direction bit is not set since the message is from the outstation. The destination is 0 and the source is 1, reversed from the request. And there are our two header CRC octets. The transport octet is a hex C0 with fin and first set and using sequence number 0. The application header starts with a hex E7, which sets the fin, fir, and confirmation bits and uses sequence number 7 as in the request. The function code is hex 81 or decimal 129 for response. This is followed by two internal indication octets, both all zeros, as there is nothing to report. The first object header is 2 for binary change events and variation 2 for reporting events with time. The qualifier is hex 17 used for a count, followed by 2 for a count of 2 events. The binary event starts with point index 1. The state flag octet is 1, representing a state of 0 with the online flag set. The next 6 octets are the time, with the 2 CRC octets inserted right before the last time octet. CRC octets are inserted at every 16 data octets. The second event starts with 4 and hex 81 for 0.4, a state of 1, and the online flag set. The time is in the 6 octets from B9 to 01. Since we have more application octets, there should be another object header, and there is. It starts with hex 20, decimal 32 for analog events, and variation 2 for 16-bit. The qualifier and range are the same as for binary events, specifying 2 events, each with a point index prefix. The first event starts with the point index 1 and flag octet 1 for online. The value is a hex E803 or decimal 1000. Note we have another CRC code between the two value octets. The second event starts with the point index 3 and has a flag octet of 5 for online and comlost. The value is 0. And there are 2 terminating CRC octets to end the message. And the last point I am going to mention is about subsets. During the prior lessons, we have frequently talked about subset levels 1, 2, and 3, and we have talked about the capabilities of DNP3 that are contained in the subsets. But we never talked much about the differences between subset levels 1, 2, and 3. Well, now is the time to finally do that. First, please note that the subset levels are just the minimum that an outstation may implement. It may implement more. For example, while a level N outstation must support all requests required of such an outstation, some may support more features. It is okay to support additional features as long as a response does not include something that is not part of a subset. For example, a level 1 outstation is not required to support an explicit read for the analog input object group, but it can. However, level 1 only allows 16 and 32-bit analogs, not floating point. So a level 1 outstation is still allowed to support an explicit read for analog inputs, but is not allowed to respond with floating point values. It can, as long as the master and outstation both support floating points, but such an implementation and agreement would be outside the subset requirements. When stating a certain subset must support a certain capability, support just means that the outstation understands the request and responds appropriately. While an outstation is required to support requests, it is not required to be configured with all point types admitted to the subset. For example, there is a requirement to support analog inputs. If an outstation has no such points, an appropriate response to a read for analog inputs is one with the object unknown internal indication flag set. It can return the analog inputs if it has any, or it can return the object unknown response if it doesn't. Features that a level 1 outstation must support include binary, analog, and running counter inputs and events, reads of class data only. Explicit reads for binary, analog, or counter object groups are not required. Binary and analog output controls, and binary and analog output status points. Explicit reads for the binary and analog output status object group. Write of the restart internal indication, cold restart, and time synchronization. A level 2 outstation must support everything required of a level 1 outstation, plus frozen counter inputs, but not events, counter freeze requests, reads of binary, analog, and running and frozen counter static inputs using the all qualifier and variation 0. This returns all points with a variation determined by the outstation. Reads of analog and running counter events using an all or quantity qualifier and variation 0. Reads of binary events using an all or quantity qualifier and any variation. A level 3 outstation must support everything required of a level 2 outstation, plus frozen counter events, reads of binary, analog, and running and frozen counter static inputs using the all or a start-stop qualifier and any variation. Enable and disable unsolicited reporting by class and assign class.